We did the previous example using kind of longer terms, 10 years, 30 years, but most forward rate agreements are relatively short term. And there are a few minor institutional details. In the money market, the way rates are quoted, they are quoted on actual over 365 basis, which means the rate that you are given is a kind of an APR, assuming 365 days, during the term. For each of these, first let's calculate price of a $1,000 discount bond. So if you have a bond that's going to pay you $1,000 in 3 months, which is thought of as 91 days in bond market, in money markets, you get to $1,000, you divide it by 1 plus the period interest, which is the rate times number of days in the term divided by 365. I do not know why we have that. Of course, A5 is not a number, so let's put in the 1,000 right there and there. So if the 3-month rate is 2%, this bond is going to trade at $995.04. No problem with the 6-month rate. 6 months will be thought of as 182 days. Now, as we have seen in the theory part, for the forward rate to be right, the price of a discount bond that is in the future, which means you're going to pay a certain amount 3 months from now, and 6 months from now you will get $1,000. And to calculate the price of that, you multiply 1,000 and you multiply that with the ratio of the longer term bond and shorter term bond. So if I'm going to receive $1,000 6 months from now, 3 months from now I need to be paying $994.08. From that we could actually figure out the rate. The regular rate is going to be 1,000 over the price minus 1. So that would be the interest rate for the 3-month period. We need to convert that into APR term, which means we're going to multiply it by 365 and we're going to divide it by the number of days in the forward period. So this means the forward rate is going to be 2.388. To see that that is the proper rate, first let's borrow for 6 months. Not months, months. If I borrow $1,000 for 6 months, I'm going to pay 1 plus the 6-month rate times the number of days divided by 365. That's $1,010.91. Borrow for 3 months and roll over at forward rate. I'm going to borrow $1,000 3 months from now. That's going to be 1 plus the 3-month rate times 91 over 365. So 3 months from now, that number is going to be $1,004.99. Then I'm going to roll over that amount at the forward rate times the number of days in the term divided by 365. And the difference. If I have done everything correct, that number should be precisely 0. Just to make sure, I'm going to add some more digits to that. Nothing. It's just 0. Using this setup, I can pretty much calculate any one. Let's say I want to borrow for 6 months, but I want to start borrowing 2 months from now. Now, I want to borrow 2 months from now, and I want to borrow for 6 months. That means the repay is going to be in 8 months. So if the 2-month rate is 1.5, 8-month rate is 1.2, then forward 2-month forward 6-month rate is going to be 0.897. You probably realize that in this case, forward rate is indeed lower than both 2-month rate and 8-month rate. That's because in this case, the yield curve is downward sloping, which means as the yields go up, as the maturity goes up, the yields are going down. If it was the other way around, the yield curve was upward sloping, which means longer term interest rates are higher. So 2% versus 2.5. The 6-month forward rate is going to be actually higher than both of them. So just because you find a forward rate that is smaller than either of them doesn't mean you've done it incorrectly.